So we are the project group 7. We're made up of lab group 7, which is Brandon Trainer, me, Mason Wortman, Luke Carlson, and Adrian Epp. We also have lab group 12, which is Zeb Parsons, Parker Kirby, and Trey Wright. So our project challenge, as we stated last week, was essentially just throwing balls, trying to make it into a target, and having autonomous collection. So we've gone through and we've refined it. We've got a finalized design for everything. Essentially a basic layout of what the robots need to be able to do. We'll be doing the group 7 update. For our time management and organization, Luke has been working on all the pseudocode for robot programming. Mason has been designing the robot chassis and will be assisting Luke in the programming. And Adrian and myself will be working on the turret design and programming. And we got our Gantt chart set up for the rest of the semester.
So we already have all of the parts that we need, all the robot parts that we need, and everything else that we'll need will be 3D printed. So we have all of that in order and ready to go.
For our robot design, we'll be using an Arduino Mega 2560 as the main controller. It will be a 2-level chassis with the wheelbase having a single motor drivetrain, and then the turret base, which will clip onto the wheelbase up on top. That will include our rotor, and that rotor will have elevation and swivel control. And the turret will be made up of a plunger made from a servo and a set of flywheels to eject the ball out of the turret. So the next steps are finishing the turret and finishing the pseudocode so that we can begin the real coding. Begin 3D printing the chassis once I finish designing it, and then designing the circuit for the motor controls.
So group 12, Zeb Parsons, Parker Kirby, and Trey Wright. We'll do a quick update on our Gantt chart. You can easily see our progress. Our completed tasks are highlighted in the green, whereas on the stuff that's not yet completed, you can see we've assigned them to person based off of their color. And our decision matrices that we use to kind of help us guide our design of our robot. Now we have our launching decision matrix, where we considered a couple of different styles or designs of launchers, and our locomotion matrix, which we have our multiple types of moving our robot around.
So lab group 12's robot design will be using the rail system like Trey said, and then it'll be using a spring pullback system. So if you see on the front isometric view of the barrel, the bottom's cut out. So the plunger will be able to be pulled back using a gear train with another motor. These designs are 80 or 75% of the way complete. They're not all complete yet. Still need to change some things, some tolerance values, and then go about weight reduction so our motors don't need to work as hard as they do. Next slide, please. So here's some 2 more views of our robot design. On the left side view, you can see kind of how the robot will be sitting on the rail system. The larger wheel is the driving motor, and then the wheels on the top and the left side of the rail are pretty much boogie wheels, so allows for the robot to freely move on the rail system without too much friction to the point where it wouldn't be able to move. And then the bottom view is just another view showing you that layout.
So with this project, we have a lot of our parts have already arrived, electronic parts, 2 motors, some line following sensors that we potentially might use on the uh, the robot. I've got a couple of Arduino boards, and then I guess as you saw before, we will be 3D printing a lot of those plans. And we'll need to purchase a couple more things for that robot. And then for next steps, I guess, yeah, finalize the part designs, and then begin the 3D printing process. And then hopefully assemble pretty soon so that we can start doing the prototype testing and see how we need to adjust our designs and I guess just see how well it works. And we're finishing up the circuit schematics and looking at using parts we've learned from other classes to do so.
So we want to touch a little bit about the report and some design considerations. As you see in this picture here, that's from one of my previous internships at Graphic Packaging in Mitchell, South Dakota. They use autonomous robots to transfer their product from one assembly line to the other. So I just kind of wanted to show this and kind of compare our robot as almost a mimic of that. These robots in this factory operate off of the beams. So every direction, the X, Y, and Z is all by the beams. So in our robot only moves in the, I guess, across the playing field. So if you wanted to call that the X direction, our robot doesn't move in the Y direction or the Z direction. So that's something to consider. And then section 2 of our report, we're starting on the Arduino coding and the circuit boarding and all of that documentation, making sure that we are on track with that. So if anyone has any questions, you can reach out to myself or Brandon Trainer via email.